I'm going back to the original screen now. Today it's nearing the end of a year now for the story of big bangs, including the recent geological past. Only yesterday on the news we were told that Semeru in Java has erupted in the last couple of days, and this will no doubt cause great distress amongst the locals who settle the flanks of these volcanoes. Notice Java as the inset with all its volcanic arc running along the length, which effectively goes all the way along Sumatra as well, and through Bali and to the east, due, of course, to the subduction of the oceanic part of the Australian plate. And you can see that line of subduction across the centre of this Google Earth picture as a crease. That's the subduction trench. And of course, when the Australian plate gets to about 100 kilometres depth under Java, you get this long line of volcanoes resulting from the melt forming or the magma forming at about 100 kilometres at the base of the plates that are interacting in this subduction zone. Tragic for those on Java with such a dense population. It's not gone off with a huge bang. In fact, there's two active in that region at the moment. One's in the Philippines and the other's Kerinci to the west of Semeru, if you look at the inset diagram there. That's been erupting since October, I believe. Very volcanically active part of the world. Another eruption of this week has been the big island of Hawaii. News last night told us that lava flow is probably going to cut the main north-south highway between, that's on the big island of Hawaii. There's activity going on. There's one active in Russia at least, and I said previously one in the Philippines. Tonga reacted in January with a huge explosive reaction, and understand this is the biggest bang of the century. It was rather dampened by the fact that it occurred essentially in the ocean, although it destroyed a small island. There were two explosions on the 14th and 15th of January that had plumes going 30 kilometres at least up into the stratosphere. And there were tsunamis that damaged Tonga severely, in addition to the very heavy ashfall. But the undersea volcano got a diameter of 20 kilometres, and it rises nearly 2 kilometres from the seabed to the west of the Tonga Trench. And you can see that in the inset. Tonga Trench goes down all the way to the North Island of New Zealand. The Pacific Island of Tonga sits just to the west of that, again where the subduction zone probably reaches a depth of about 100 kilometres. The Tonga Trench is actually the second deepest in the world, I think, next to the one that occurs along the Philippine plate in the Western Pacific, where the deepest parts of the ocean occur. It's remarkable that within a week or so of the eruption there in January, you had very high sulfur dioxide levels registered over Mauritius. So there was a great spread of gases erupted from that. And of course, the lower picture here is the main eruptive event captured from satellite image, and stuffed in the middle of it is poor little capital of Tonga. You can see a right angle arrow going into that. And this cloud not only went up 30, maybe even 50 kilometres, I think 30 kilometres or so, it extended for several hundred kilometres, and the ashfall was very severe. Probably when we're talking big bangs, we think of Krakatoa in 1883, and it's one of the deadly ones of history. 36,000 people, we believe, were involved in the tsunamis and the ashfalls that occurred over the southern section of Sumatra and western section of Java. It caused an enormous change, as is illustrated by those very early maps. The pre-eruption picture is shown on the left, and the post-eruption, sorry, I don't know the actual date, that second one is drawn up, but the circle that I have put on the diagram is probably the dimensions of the caldera or belt that was blown out at the time of the huge eruption that was heard in Melbourne, certainly in Western Australia and in Mauritius. And it travelled around the world 7 times in the next 5 days, that compressive sound wave. And the actual explosion triggered off tsunamis up to 40 metres high. And they traversed the entire Indian Ocean, of course, and we don't even know the full extent of damage across on the western side of the Indian Ocean, but it destroyed up to 300 villages along the Sunda Strait. Many of these huge bangs occur after a period of heightened activity, maybe even several months of eruption, and then a huge one, which suggests that there's a very large magma chamber at depth in the crust, not an enormous depth, but sitting perhaps only a few kilometres down, at my guess, that has been triggered to suddenly degas and explode with enormous power. So Krakatoa is probably the loudest bang of the last couple of centuries. And where is it? Well, between Sumatra and Java there, and that's the same circle. And the island distribution is a bit different today because Anak Krakatoa, the daughter of Krakatoa, has built there where the little red marker occurs. And probably the caldera is about nearly 20 kilometres in diameter. And it was an amazing location, of course, for the occurrence of tsunamis in relatively shallow water. That's a bit more detail, just showing Anak Krakatoa. Not quite sure why that Google image has the bits separated on it. I'm sure they're not pasture lands. I think it's some mosaic of photography. Anak Krakatoa, I think, had mainly built as it stands today by about 1920, some nearly 40 years after that explosive event. When we're talking about big ones resulting from subduction, there are many, many of them around the world. No doubt in the Pacific Rim you could find 20 or 30 examples quite equal in size. Here's another one in the arid highlands of the Andes in Argentina, Galán. It's a caldera or subsidence zone of about 20 kilometres east-west, probably 25 or 30 even north-south. Looks like an egg with a raised yolk in the centre. That's what we'd call a resurgent dome, indicating that there's some pressure from magma underneath. And of course, always a risk when domes such as this grow, that there'll be another huge volcanic explosive event. There we have yet another of many, many more. This is only one of a whole series in that belt along the Andes. I've just made this note here from the web. Is it a lookalike for Krakatoa? Well, no, because it occurs really within a continent, with a mountain system of a continent, but the origin is very much the same because you still have subduction going on at relatively shallow depth under the Andes. And we've commented that the caldera, which is the collapse zone from which magma was erupted, probably as a huge ash deposit, crystal ash, fragments of magma having been violently erupted so that individual crystals were the main explosive product. And it's underlain by a magma chamber, which I can't read exactly, but about 22,000 cubic kilometres probably of magma lying in there, as has been determined by geophysics. It's the indirect consequence of subduction of the Nazca Plate beneath the South American Plate, Nazca being the eastern side of the Pacific Ocean floor in that region. However, they were speaking here of secondary magmas. In other words, the main magma probably developed at 100 kilometres or so, but a huge body of magma has resided within the crust and gradually assimilated or gradually melted some of the crust. Its temperature would initially be about 1200 degrees, and the crust melts at about 600 or 700. So it's been contaminated by silica-rich crustal rocks, and it therefore becomes much more sticky, much more gaseous. That's different from a basalt, quite obviously. The main effect is that being sticky, it can result in huge explosive events which fragment everything to essentially crystal form rather than rock fragments. We're saying here that the largest eruption of this Galian was about 2 million years ago. The volume of the ignimbrite, which is the material expelled, all this crystal magma, been estimated to be about 650 cubic kilometres. So it was an enormous amount of material produced explosively. And just a comment that a volcanic arc runs along between the borders of Bolivia and Argentina with Chile, and behind this volcanic arc lies this chain of rhyodacite or silicic volcanoes that have dissolved silica from the crust. And Galian is the southern member. The whole region has been subject to all sorts of huge eruptions of crystal ash. Many of them have produced volumes larger than 100 cubic kilometres. Not the place to be living, and not too many people do in that arid highland area. When we're speaking of large eruptions, of course, we think of the supervolcano Yellowstone. Its main eruption of over 2 million years ago is the largest of super eruptions that's known. And there's a collapse zone of 30 to 50 kilometres diameter there, which is illustrated in this diagram, really. Again, there's a resurgent dome, and at times they've been very anxious in the Yellowstone National Park because they've been able to measurably watch the rise of a resurgent dome, nearly 10 kilometres in diameter, which, of course, very anxious with the amount of tourism and travel that one gets through Yellowstone, that doesn't suddenly catch up with them with one of these huge eruptions, which has an effect over a lot of the United States. It too spreads silicic lava. That's a very sticky, not lava, I'm sorry. It spreads ash formed of crystals, which just spread out over the landscape, a lot of them horizontally in huge turbulent flows that travel at 80 and 90 kilometres an hour, just engulf everything surrounding them, resulting in thicknesses of several metres, 3 or 4 metres or 5, 10 metres of asphalt turf. We can see in this diagram that you get earthquakes all around the location of this giant volcanic centre, because it's somewhat different. It's not due to subducted plate. It's apparently due to a hotspot way down, 3,000 kilometres down, emanating from the outer core of the Earth, rising as a plume of heat to form a big magma body at the base of the crust, which is then periodically erupted over 100 million years and more. And of course, that's reflected by the plate moving over it and leaving areas of derelict volcanic material that no longer has a hotspot source. Another hotspot, of course, is Hawaii. Now, everything else we've spoken of today has been subduction volcanoes, but this is the other type due to a very, very deep source of heat. Looking quickly at that region, for those who've travelled there, no doubt the Teton Range is one of the most remarkable features of that region, but the outline in red here is the most recent. It's a very, very dangerous region, but the big eruptions are probably every some areas. It's very clearly defined, but there are domes within it, like the Mallard Lake Dome, the Spur Creek Dome. And there are subsidence regions as well, where magma's probably moved away, resulting in lakes like the Yellowstone Lake or the West Thumb. Very, very dangerous region. but the big eruptions are probably every 600,000 years or so. That's one section of the northern margin, just showing the caldera, really, rather than crater. It's the collapse zone from which magma has been evacuated at depth. There's a series of the Yellowstone caldera outlines with the Mallard Lake Dome and the smaller dome, or another one, the Sour Creek Dome in the north there. And their ages range from 150,000 years ago to 630,000, which was the youngest of the main Yellowstone calderas. And that's probably stretching for 30 kilometres from the southwest to the northeast. It's just a complex which has continued in time. In fact, if you look at the Snake River plain to the west of it, running down in almost to Nevada, you can see that 16 million years ago, in the 9 o'clock position, you had volcanic activity, and gradually, by the centre of the diagram, it was 8 to 10 million years ago, whereas now the plate movement, last major activity, was 630,000 years ago. Another area of huge eruptions, of course, is the Taupo volcanic zone in New Zealand, of which White Island, tucked right up there in the Bay of Plenty in the top right of that diagram, erupted on 19th of December 1919, I think, before we were troubled by COVID, and my grandson and I, Nick, had planned to visit that day, but fortunately decided to spend our time around Lake Taupo instead. And Lake Taupo is essentially a collapse zone or caldera, and there are perhaps a dozen in that Taupo volcanic zone. The present-day volcanoes of Tangaroa Ruapehu are the classical subduction-style volcano, and the subduction occurring along the east coast, or just off the east coast of this North Island, New Zealand. But Lake Taupo and Rotorua, etc., have been more mixed with the crustal rocks, and they are of the variety that spread the ash with a lot of silica in it, to crystal ash, that has affected a lot of the North Island of New Zealand. Taupo's main eruption was 25,000 years ago, and it produced over 1,000 cubic kilometres of debris. So it was a big one. And that debris was more in the nature of crystal tuff, a few millimetres in size, erupted as a huge cloud which would have spread over the landscape with dynamic turbulent flows that poured over the landscape, irrespective of valleys and hills, leaving behind, in most areas, several metres of cream-coloured ash, not the grey that you'd expect from Ngātamarui or Ruapehu, but a lot of feldspar and quartz involved, which is indicative of those magmas having interacted with crustal rocks. There was a major eruption before Maori settlements, somewhere around 186 AD. That's been considered one of the largest of the last 10,000 years known on Earth. It was a 50 cubic kilometre volcanic ash and debris deposit. We use the word tephra for the mixed style of material that comes from volcanoes, including large blocks down to fine ash. And pyroclastic flows, well, they're the things that stream down mountainsides or rush across and cover a place like Vesuvius. I'm trying to think of the town that was enveloped by ash there. Extremely hot ash circulating in turbulent flows and coming at extreme pace. These in the North Island of New Zealand destroyed over 20,000 square kilometres of countryside. And that too may have had an ash plume which reached into the stratosphere, 30 to 50 kilometres. And in blue there, the subsequent caldera substance of Taupo and related eruptions, Rotorua, etc., are of world scale. They're big ones. Perhaps the real big one of recent times, I say recent times, Lake Toba, Indonesia. It's in northern Sumatra, more or less along a central strip, which is a major fault zone or volcanic belt all the way down to Java. In fact, if you look on this diagram, running from about 10 o'clock, fault line quite evident. And I think there's a very strong line runs right down through Sumatra, which is the focus of many volcanic centres. Well, this one's a big one. That 50-kilometre scale shows us the enormous size of that subsidence caldera, and Samasir marked in the centre, which would be a resurgent dome, I believe. It's elongate, reflecting this overriding trend northwest to southeast, I believe, that parallels the subduction zone to the west of the Australian Indian Plate. So that's a big one, and we've got a few facts about that to follow. This view was of the caldera from space, of course. It measures about 100 kilometres by 30. That's most of our southeast region. The steep-walled caldera contains Lake Toba, and it's the largest volcanic lake we know of. Erupted at least 2,800 cubic kilometres of magma in a single event 74,000 years ago. It ranks as the largest volcanic eruption of the Quaternary geological period, and that's Pleistocene and recent, or 2.5 million years. And I reckon it's something of the 8.8 magnitude eruption. It makes 9 almost difficult to imagine and 10 impossible. A vast proportion of North Sumatra was drowned in ignimbrite. That's that deposit resulting from these ash clouds, and these extended from coast to coast. Large areas were blanketed in Southeast Asia, and including small ash falls on the entire subcontinent of India. An aerosol cloud, dust cloud, probably encompassed the Earth and would have had climatic effect, there's no doubt, initially causing prolonged winters and years without summers. As in the case of the South American subduction system, at Galan in Argentina, the Sumatran subduction by the Australian plate has produced this supervolcano. The erupted lavas have become increasingly sticky with their time in the crustal magma chamber, and the result has been enormous crystal ash eruptions known as ignimbrite. That's the rock is known as ignimbrite. It has very distinct characteristics, which include fragments of molten material and the like. There's no respite in these big ones. We go to the Aegean, of course, and you've got the African plate subducting under Eurasia, of course, or Europe itself. The island of Thera, which is another name, I think, for Santorini, may well be the Atlantis myth of destruction of an island with the loss of an advanced civilization. And there is the remnant of a town at the very bottom there at 6 o'clock being excavated at Criteria. So it's really a most outstanding example of part of an ancient and lost society. It's about 12 major eruptions have been registered. The Bronze Age Minoan eruption ranks as about 7 on the volcanic explosive index. It's less than a tenth of what we consider happened for Toba. It ejected somewhere between 30 and 90 cubic kilometres of magma. It was a catastrophic eruption, however, and it devastated this island at circa 1600 BC and destroyed the Minoan settlement at Akrotiri, as well as communities and agricultural areas on nearby islands, and much of that region of the Aegean must have been affected by enormous tsunamis, etc. The tephra, that is the material that came from that explosion of 1600 BC, serves as a marker horizon in most archaeological sites in the Eastern Mediterranean. So it was very widespread. And its precise date is debated still, so that they'd like to pin it down, to within 20 to 50 years. It is still a subject of much debate. There are no clear ancient records of the eruption. Its plume and volcanic lightning may have been described in the Egyptian Tempeste Stele and the Chinese bamboo annals reported unusual yellow skies and summer frosts in the Shang dynasty. It may have been a consequence of volcanic winters similar to 1816, which was the year without a summer after the 1815 eruption of Mount Tambora in Indonesia. Here's a picture of the excavation southern region of Santorini, and it's been excavated since 1967. There's quite a bit of pastoral activity goes on around it in that region of the Caldera margin at Santorini. The comments here are that it was well placed on the copper trade route from Minoan, Crete, and it became an important centre for metalwork, and they've been able to demonstrate that in this excavation work. From about 2000 to 1650 before Christ, Kritiri became more urbanised with paved streets and extensive drainage systems. Quality pottery was a mass production, and they decorated this with lions and plants and animals. Metallurgy, other crafts, particularly related to the maritime industries, were more specialised. And there's also evidence of repair and rebuilding projects following earthquake destruction. Tambora in Indonesia, here it is with a little inset at the same scale of Pompeii. So it was a big one. Tambora, 1815. It was well recorded by the British. So the crater of Tambora and its 1815 eruption is really outstanding. It's still an active stratovolcano, non-Sumbawa. That's easterly of Java, of course, and Bali. There were a series of eruptions in 1815, culminating the largest of the last 10,000 years. The magma chamber has been drained by previous eruptions and underwent several centuries of dormancy as it refilled. Heavy volcanic ash rains occurred as far away as Borneo and Sulawesi, Java, etc. And the elevation of Tambora mountain was reduced by 1,400 metres. There was a whole population effectively wiped out on the island, and a language was lost. And the death toll was at least 71,000 people. Eruption contributed to global climate anomalies in the following years, particularly in Europe, which suffered drought. And this was 1816 was the year without a summer because of the impact on North American and European weather. Livestock died, and that was the worst famine of the 19th century. Here's an illustration, dense dark there, but you can see Java with Batavia or Jakarta marked, and Sumatra off at 9 o'clock, Borneo or Kalimantan in the north, Sulawesi, Timor in the far southeast here. So this is the distribution of direct ash fall from that eruption of Tambora, a centimetre over the southern regions of Borneo and Makassar, and up to 50 centimetres mostly in the Sunda Bay area of the Lesser Sunda Islands. Well, I popped this one and can't avoid these, can I? The plate tectonic setting. This shows, well, the Australian plate in the south and what's called the Sunda megathrust. The number 59 at 7 o'clock is indicating the direction and amount of movement per year, 59 millimetres. That's 59 kilometres every million years. The Australian plate is slipping in under that blue jagged line and sliding in under Indonesia. If we go up to the northwest of it, we see the purple line and the red green patches, 90 East Sumatra belt. There's a grey area on the tectonic map there suggesting there's a lot of disturbance going on in that region of the plates. Effectively, the Indian plate has stopped its movement to a large extent, and the Australian plate is breaking away from it and sliding or separating because it's not severely impeded as a result of being mostly oceanic crust subducting beneath Indonesia. Look at the mess going on in the Banda Arc at 3 o'clock. All those belts of subduction, of sliding, of stretching, of crushing. That's no wonder there are active volcanoes in that region at the moment. That red spot is Tambora. And of course, the Pacific plate is coming in there from the southeasterly direction, also at a great rate, 92 millimetres a year, Turkey's head of New Guinea. That's very rapid movements. I've made a sudden change here to Central Australia, Goss's Bluff in the McDonnell Ranges, southwest of Alice Springs. For many years, it was a bit enigmatic. People called it cryptovolcanic or hidden volcanic, weren't quite sure of its origin. I was given the task as a student in the mid-1950s to try and do an interpretation of it. I actually was not aware of all possibilities in those days, but I thought, oh, that's got the geometry of a salt dome, which we see in the Flinders Ranges and the Gulf of Mexico and these regions. I only said it has the geometry of it, which is quite correct. It's actually like the rebound when you see a drop of water go into a pond or from a tap into a bath or something. There's a reaction blob comes up, and that's what Goss's Bluff is. You can see that surrounding it with a diameter of about 30 kilometres, there's a diffuse zone, a circular zone, and the central splash is effectively the blob that's come up as an elastic rebound from something. And it was in probably the mid-1960s, 1970 certainly, that it was appreciated that Goss's Bluff was an impact from an extraterrestrial body. Next fortnight, I'll go on and talk about some really big splashes that have occurred over time and big bangs when body Earth has been hit by extraterrestrial bodies. Some of them are referred to as astrobleams, things like this one, Goss's Bluff, where they're complex, not just a crater like Meteor Crater in Arizona, but this one and others like it have central rings or elastic rebound domes in the centre. And they're the extreme impacts from bodies that have been travelling through space at 15 or 20 kilometres a second. These, on hitting Earth, if they're larger than 100,000 tonnes, entirely vaporised, so you don't get any evidence of the meteorite itself normally, just a fragmentation of the country rocks and the change of minerals and the structures which indicate that they were formed by intense pressure and the immediate heat transformed as the body's absorbed into the Earth in the space of seconds and then vaporised due to the transfer of momentum into heat. There's a view of the inner uplifted dome of Goss's Bluff. It's quite well documented geology of Ordovician age, should I say, but there are very characteristic features in it which demonstrate that it was an impact rather than a volcanic phenomenon. Also, it has no depth. They've been able to show that down at about 4 kilometres, there's no influence in the geology, so that there's no deep root of magma or anything like that. The inner uplifted dome of Goss's Bluff brings up strata from several kilometres depth and folds them up in a dome effectively, which has been eroded off probably by a kilometre or more. There are no associated volcanic rocks, much intense fracturing and debris. We'll look at its history next time, but it was an impact in the age of dinosaurs about 142 million years ago. And this is now the roots of that impact after its erosional history. And here's another one looking down at the folded strata of the McDonnell Ranges and the location of Goss's on the plains near Hermannsburg. I've marked King Canyon down there at 7 or 8 o'clock to give you some location. Alice Springs would be an equal distance out to the east, just out of this view. Ormiston Pound, I think I can see there at about 2 o'clock. Structure that looks a bit like the head of the New Guinea turkey. that's a really unique feature of Australia, the Gosses Buff impact. And there it is again, showing the central dome as was known in the 1960s, and the area that I was given to try and interpret as a young student geologist. The idea that I had is shown as an inset there, that it looked to me as if salt might have risen from the strata well below it. But today we know that the light brown, as distinct from the fawn intrusive material, is actually fallback debris. And there's a whole suite of information that indicates that it was an impact structure 142 million years ago. And there she'd be again, showing you the main region around it, affected by the impact, probably at a depth of several kilometres below surface. And when we're talking of big structures, as we will in a fortnight, perhaps the biggest is the Breadfoot Dome in South Africa near Johannesburg. You can see that line AB is 80 kilometres, and you've only got a partial circle illustrated there, which is one of these inner circles of a huge impact structure. And if you look down at the bottom cross section, you'll notice the same red bar of 80 kilometres is across that dome region in the centre of a huge impact phenomenon. So it stretches out for several hundred kilometres effectively from Johannesburg in the west there, where you can see the present surface line. You notice Johannesburg written bottom left, and it illustrates a little black image of the city, and that's the present surface level, whereas the diagram tends to illustrate what it must have looked like pretty soon after the impact, so that whatever it was disappeared effectively deep in the crust or into the mantle maybe, caused elastic rebound, which we only see portioned today, even the roots of it, and most of the impact ejecta has been removed by subsequent erosion over a period of 2 billion years. So there's a central dome, and then rocks were deposited around that. We'll go into more detail next month. I think I'll leave it at that point because my throat seems to be showing a little bit of reaction to things, but hopefully we can go into question time. Anything you've got to ask?